All right. Hello, everyone. Thanks for waiting in the audience. Thanks for waiting for us to start. And yeah, welcome back again to another episode of PyTorch Community Voices. So I know we're coming to you at a slightly different time, but we're excited to have Robin with us today. So to begin, I'm Jessica, one of your hosts. I'm a developer advocate here at Facebook, focused on our AI, ML, open source projects. And so today we're really excited to have Robin Lobel from the creator of TorchStudio. So I was really excited to hear about this project. So it's an IDE actually that helps users easily train their own AI models, as well as be able to get visual feedback. So it's really interesting to be able to see the tools that people are creating for creators like yourself to use PyTorch. So today, Robin will be demonstrating to us how to use TorchStudio, how it helps us create, train, and iterate on PyTorch models. In addition, to be able to allow users to access common PyTorch datasets, as well as create their own custom ones. So before I go on any longer, I will bring on Robin to talk more about it himself.
Hi.
Hello. Hey.
Hi. Thanks for having me on this episode of PyTorch Community Voices.
Yeah, happy to have you. Could you give the audience a quick intro of yourself?
Sure. So for the past 10 years, I've been working on an audio software called Spectral Layers, which is being distributed right now by a company called Steinberg. And this software, which I've been working on, it's now version 8, I think, of this software. I had this idea. I mean, I'm giving a little bit of background of why I've worked on this audio software first, because this led me to TorchStudio after. So the reason I created this audio software was for, at that time I was in film school and I was doing shooting some short movies in the streets, and I really needed a tool to get rid of the background noise. And none of the tools that were available at this time were sufficient for my needs. So I started creating this software, and turns out that as I was working on it, I could see other use cases that other people could certainly find and interested for. So I started making it a general tool for cleaning up sound. And in the end, it turned out to be a sort of Photoshop for audio. And so during the past couple of years, I've started to get interested in AI, because obviously this is the big topic, the big trendy topic these days. And it also has, I mean, there are a lot of application in image recognition, but there is also a lot of processing to be done for audio using AI. And it was definitely a good match for Spectral Layers. So I started to look into it. I mean, I was not that much familiar with AI 2 years ago. I started looking at the different frameworks that were available. And soon enough, PyTorch became the obvious choice. And I started creating my own model. At that time, it was for the version 7 of Spectral Layers, which was released a year ago, I think. And after working for a year on those first AI tests for Spectral Layers, I realized that I would need a tool which will allow me to be more efficient in my AI researches. So from this point started this idea of TorchStudio. And the similarity here is that, like Spectral Layers 10 years ago, I started creating TorchStudio for my own need and my own AI research in audio. And it turns out that as I was writing this tool, I also realized similarly that it could be useful for other people as well. And I started to design different kind of UI and see how people were using AI and how it could fit all into one software. I mean, maybe not every kind of AI research, obviously, but the most common kinds. And I started writing TorchStudio 8 months ago, something like that. And I used it for my own research on Spectral Use 8, which was released a month ago. And this was the proof of concept that there is definitely some added value here in having such a tool. So I was aware that there were also some other helping frameworks like PyTorch Lightning and other. I mean, there are a lot of helping frameworks for AI right now, but this was not specifically what I was looking for. I really wanted something that had a new UI and which you could use with the mouse and being able to organize simply all your different model tests. And so now I've reached a point where TorchStudio is usable. I mean, it's not fully finished yet, but it's definitely advanced enough that I can show it to you today.
Nice. Yeah, thanks for taking us through that history. So for those of you who are just joining us, so Robin is the creator of TorchStudio, which is an IDE to help machine learning people in machine learning train their models, create and train their models. So he's coming from a really interesting background. Sorry, I realized we're filming at a very different time of the day, so the light in my house is quite different.
Yeah.
I can avoid being in the sun, like catching the sunlight.
I'm in Paris.
Yeah, so he's in Paris, we're in California, so very two different time zones right now. So Robin came from he was talking about being in film school and then trying to create a program that was helping his own audio situation in that film creation and creating spectral layers, and then the evolution of that, creating TorchStudio that actually helps with analysis of some of the work in spectral layers, which I find really interesting. And the fact that you also created an IDE in 6 to 9 months, we definitely will have to pick your brain about that. Yeah, like how did you set all that up? It seems like there are sort of some folks in the audience reacting quite astonished. So we're all really excited to see this project. So with that, do you have anything else that you want to add about TorchStudio before we dive into the demo today?
Yeah, well, I think the best would be probably to show it live. So for this episode, instead of showing you a PowerPoint of what TorchStudio is, I thought it would be a better idea to show it live and how I interact with the software and how other people can use it. And yeah.
All right, so let's pull that on screen. And yeah, for those who are in the audience, please make sure to add your questions. Just add your comments and questions. Yeah, we'll be happy to have Robin help answer those live. So I'm gonna add his screen, and then I'll take myself off then as you're doing the demo, so folks can focus on you and your presentation.
Okay. All right. So this is TorchStudio. The first time you launch it. So TorchStudio is a standalone software that you can install on Windows, Linux, or macOS. It weighs a couple hundred megabytes. And if you don't have a local PyTorch environment yet, it will automatically install one. And so TorchStudio is organized around tabs. So the first tab you see, and the only tab that's active right now, is the dataset tab, because this is the very first start of your AI research. You usually already have a dataset to start with. And for this example, I would start with the very well-known NIST dataset, which is basically the hello world of deep learning. So you don't have anything to configure for a lot of dataset that comes with PyTorch. As you saw here, I just choose to take a dataset from TorchVision, the NIST dataset, and I can just click load and it will load the dataset. So if you don't have the dataset already on your computer, it will automatically download it. And as you can see here, it already pre-configured most of the parameters that you need to properly load and play with the dataset. So once the dataset is loaded, well, the first thing that you will notice here is that you can see the inputs of the dataset, which are handwritten digits. And at the bottom, you can see the output tensors of the dataset, which are the human interpretation of those handwritten digits. And in between those two panels, you can see, well, you have some controls to format your dataset. So right now, it's using the default balancing from the NIST datasets, which is 60,000 samples for training and 10,000 for validation. But I could, if I want to, I can change the balance here depending on my needs. So I'm going to revert back to the default. I can also play with the number of sample I'm going to use for the training, and I'll come back to that later. And TorchStudio automatically detected that component 0 is going to be an input tensor, and component 1 is going to be an output tensor. And it also gives you some nice statistics about the dataset that you've loaded. So the dataset is composed of 10 digits, and as you can see here from the statistics, it's already pretty well balanced with around 10% of each digit represented in the dataset. So now that we load a dataset, we can move on to the next tab. And as you can see here, this was not active before, but now that we've loaded a dataset, we can move on to create our first model. And again, I could choose a model from the TorchVision or TorchAudio library, which are provided with PyTorch. But this time, I'm going to use a model which is provided with TorchStudio itself. And in particular, a model which is already written to classify the NIST digit numbers. So that's a model that you can use without parametering anything. You just have to build it as is. And you'll see in the next panel, the graph panel, how it looks like, which is pretty useful to debug your model or see how the tensor size change going from one node to the next node, and the different activation and operation that occurs. And it's also a way to validate that your model does not have any errors or if you need to change things. So we have the NIST classifier, which is built now. I won't comment for now on the hyper parameters. I'll come back to this with the next example. I just have to choose a device for training. So I'm going to use my GeForce 3090 in this case, and I can launch the training. So now it's loading the dataset in memory. And after a couple of seconds, it should launch the training. So there we are. So as the training progress, you have some statistics about the speed of the training and where you are and how the accuracy improves. So here we see that the accuracy is actually converging pretty fast. And the last panel will show you the input tensor that you give to your model and the inference output from the model. So now it, in this case, it correctly detected that the digit 7 was shown on screen. If I go through the data set, I can make sure that it properly detected all of those digits. And that's it. I mean, that's how easy it was to train your very first model in TorchStudio. Now I'm going to move on to an example that needs a little more tweaking, because in this case it was only 3 clicks because everything was already set up and ready to go. But I'm going to use for the next example the CIFAR10 dataset, which is a collection of pictures from 10 different categories. If I load it as is, well, I don't know how much time it will take to load it. Yeah, okay, it's fine. The CIFAR10 dataset is composed of pictures which are of a size of 32 by 32 pixels, which might not be sufficient for most of the vision models that are available in PyTorchVision. So I'm going to have to tweak the size here. So as you can see, we have the details about the tensor, 3 channels for the colors, and 32 for the width and the height. And I will change this to, so I'm going to add a line here. I'm going to add transform resize 64, which is a standard PyTorch function. And I'm going to load my data set again. So as you can see, all those parameters here are the parameters that you would have for the CIFAR10 dataset, and you have the description of each of those parameters here. You can also find them in the PyTorch documentation. But anyway, in most cases, all those parameters are generally pre-configured, so you have only very few things to tweak. So now it's almost finished loading. And again, it's also a model that will be, that model dataset that will be automatically downloaded if necessary. So yeah, we will see that the tensors are correctly sized. We have 3 colors, and the width and the height are 64 by 64, and we also have the correct interpretation below for each of the pictures. So we can move on to create our model for classifying those pictures. So this time I'm going to pick not a model from TorchStudio, but a model which is provided with the PyTorch library, the TorchVision library. And I'm going to use the simplest of one of the early classification model. I think this one is from 2015. It will be a good start for our demo here. I can build it as is. But the issue that I will have here is that at the end of this model, I get 1,000 classes to recognize and classify. And this is definitely not matching my data set, which has only 10 classes of pictures to classify. So I just need to change the num classes parameters here, make it 10. And as the graph will show at the end now, it's outputting 10 classes, which is fine for what we need in this case. So now if I move on to start the training, I will reduce the space here and here to have a better visibility. If I start the training right away, it should pretty quickly run into an error. And it says that the model doesn't end with an activation function. And that's indeed the case. It ends with a linear node. And For classification problems, we need an activation node such as a log softmax. So fortunately, even though this model doesn't provide the activation node at the end, I can choose a different last function, which already embeds the activation, which is log softmax. And I'll start the training again. I'm going to increase the batch size to make it faster. And one thing I just realized is that if I start training right now, it might take too much time for the demo. So what I can do is go back to my dataset tabs and decrease the sample usage. So originally I had 5,000 samples plus 10, so 60,000 samples. And I'm going to reduce this to, let's say, 26% of the data set, which is now 13 and okay, we now have 15,000 samples. So it will be sufficient for the demo today. So now I can start the training of this AlexNet model. So yeah, we don't see much of activation or accuracy or loss curves yet. Yeah, maybe because I was zoomed out. Yeah, I was too much zoomed in. So that's why I couldn't see it. So what I can see is that the validation, the accuracy validation starts to increase gently, well, pretty fastly at first, and then it slows down. And it seems that I'm now converging to 52% of accuracy with the numbers of samples that I gave it. And remember that this is an untrained AlexNet model, meaning that it has no prior knowledge of picture classification. So what I'm going to do now is show you the difference of when I train a pre-trained models and how to do that in TorchStudio. So I'm going to create a new tab, which will be a new model. And as you can see, my previous model is still training. You can see that with the play icon here. And instead of choosing the AlexNet model with a capital A, I'm going to choose the AlexNet function with a lowercase a. And this function actually calls the AlexNet classes, but it allows me to get a pre-trained model. So I'm going to change this value pre-trained from false to true. And I'm going to build it. So if you don't have the pre-trained data on your computer, it will also automatically download it. And okay, so it built the model, but again, we run into the same kind of issues that we have with the previous AlexNet model, which is we have 1,000 tensors, 1,000 components at the end, and we only need 10. So how can I change this? Because in this case, I don't have the num classes set parameter that I had with the AlexNet model. So in order to fix this, I'm going to have to go into the code. So what you saw so far is a brief description of each model or each data set. But if I check show code, I can go directly into the code and patch this model. So I need to change this linear node, which right now takes 4,096 values in and output 1,000 values, and I want to make it output 10 values only. So the name of this node is shown at the bottom. It's called classifier.6, which means the sixth classifier of the model. So I'm going to patch the model classifier at index 6. And I'm going to replace it with another linear module. which take 4096 values in and output 10 values. I'm going to rebuild it. And the graph, yeah, the graph shows me that now that I have indeed 10 values at the end, which is exactly what I want. I've made sure that pre-train is checked to true, and I can launch the training now. And what I can immediately see is that the accuracy goes much higher than it was in the previous model, previous untrained model. So if I compare the first tab with the second tab, there is a clear difference in accuracy. And I'm pretty sure that if I find some errors here, so let's try to find a pictures. Well, I think it's more a dog than a deer, for instance, here. Let's see how it goes with the pre-trained model. Yeah, you can see that, well, right now it's not fully trained, so it's still hesitating. Let's see if I can find another example. Okay, so it's definitely not a cat. Let's see how it goes with the pre-trained model. Yeah, it correctly classified it as a bird. Well, for now, yeah. So this is a good example of how you can reuse the pre-trained model from PyTorch directly within TorchStudio. And now I'm gonna show you an example where everything needs to be customized. So so far we've used pre-made data sets and pre-made models. But as I've shown you, everything can be customized as soon as you check show code here for the model, or I can show code for the data set as well. And I'm going to import a specific data set, which this is a collection of samples that I've made for a very specific use case where I had damaged audio signals. So the input at the top are the damaged audio signals, and I needed to recover the original signals, or at least pretend that it was recovered enough that it could be audible. So what I did is that I took a lot of audio samples, normal audio samples, and I on purpose damaged them so that I would have a set of inputs and outputs where I already know the answer and I've created the damage here. So the idea was to train a model which would be able to solve this problem on my own data, and then I could apply this model to the real data. So in this case, you can see that it's a one-dimensional signal, contrary to contrary to the data set that we saw earlier, where it were mostly pictures and labels. In this case, the input and the output are both one-dimensional signals, and you can see that TorchStudio automatically adapted its visualization of the tensors properly. And actually, those visualization modules here and here are also Python scripts. So even though TorchStudio will provide you with what it thinks is best for visualizing your tensors, you can certainly define your own visualization scripts in order to get the exact visualization that you need. So, well, in this case, the default visualization modules are exactly what I need. And I'm gonna use a model which is provided by TorchStudio, a one-dimensional unit. I think it would be pretty suited for this task. And This models comes with a lot of parameters, so I won't have to dig into the code because this unit can be customized very easily with all the settings that's available here. So in terms of input and output channels, I only have one for input and one for output. And I'm going to set some basic settings. Well, that's mostly by experience because, each new AI problem is new and you have to figure out what should be the ideal parameters. Obviously, you don't know the ideal parameters, but you can in a way have a rough idea of where to start. And my rough idea right now is to start with 12 channels and a depth of 5. So let's see how it looks. When I build this unit model, you can see that TorchStudio is also able to represent complex structures with nodes and subnodes and bridge between the nodes. And I'm going to start with this set of parameters here. And I'm going to duplicate this model here just by clicking the plus button here. And then I'm going to write another set of parameters. I'm going to change the depth here to 4, rebuild it again. And while I'm doing this creation of new models, I'm going to launch the training for the first model. So train. And here I'm starting the training as well. And here I'm going to, again, make another set of parameters, and I'm going to launch this third training not in queue but in parallel. And this means that while the first model is training, the third model can train as well. Well, it turns out that the first model just finished training, but let's go now to the overview tab. And this is the tab where you can see the different performance of the different models tab that you've just created. So right now we have model 2 and model 3 competing. It looks like model 2 is better suited that model. So the loss is better for the yellow and the blue. So that means model 1 and 2 are better than model 3. And the same goes for the accuracy curve here. So that's a way to quickly identify which models are performing the best, because you can see the colors here in the list are the colors that you can see in the graph and are also the same colors that you can see in the tabs at the top. So yeah, and you also have a list of all the parameters that you've used for this model, and the hyper parameters here, which device you used, and the status you can see in real time where is it is in terms of training and how much time remains. And once you've identified your best performing model, let's say the yellow one in this case, you can see, of course, the inference, how it reconstructed the damage signal. So this is the damage signal that it takes as an input. And this is what it inferred from this damage signal. And I can compare it to the target, the actual target, because I already know the answer. And so this is what it was supposed to reconstruct, and this is what he was able to reconstruct. So it's pretty close. And close enough that I can now save this model. Well, so this is train model unit. Save it. I'm saving it as a TorchScript, a PT file. And now I'm free to reuse that PT file, that trained PT file, in any kind of application. For instance, if I have a web server providing AI results, or if I have a standalone application or a plugin, it's pretty easy to directly load this PT file using the PyTorch or LibTorch library. and I can immediately play with it and give it any kind of samples to infer. So yeah, that's I think a good overview of what the software is. Yeah, the description, I would describe it as an IDE, like Visual Studio or Android Studio, in the way that it allows you to code, but for the parts where you don't need to code, it will, set up the things for you. I see it a bit as a conductor for your different PyTorch scripts. So where you need to code some Python, you can. But if you don't need to, like, for instance, the training loop, it's really not something that you want to recode every time. And so in the background, it's running a lot of different PyTorch script and communicating with the main C++ application, which is TorchStudio. And right now, I've just sent my training to my GeForce, local GeForce, which is connected to my laptop right now with a eGPU box. And by discussing with different people how they were using AI, I figured out that local training would not be enough, because even though I have this GeForce, it turns out a lot of people are just basic laptop and don't have direct access to a big GPU for the calculation. And what I'm doing now is adding remote training support to TorchStudio, so that in addition to the local GPU that you may have, you could also send it to a remote server and just use it the exact way that I've shown for the past minutes. So you would select a remote server and start the training, and you will get the same kind of data. And yeah, so I think that's already a pretty much a good overview of the software.
Well, thank you so much for that very comprehensive dive into TorchStudio. And like you mentioned before, with it similar to Android Studio or like Visual VS Code, I think having all this utility in one place, I think really allows people to more easily build out more comprehensive models, or just be able to dive into it much easier. So yeah, thank you again so much for putting this together and building this. How about we dive into the question portion? And I think
Sure.
Last point about remote training leads well into Victor's question about can it be used for remote training?
Indeed. Well, yeah, I mean, initially it wasn't supposed to be used for remote training, but indeed, TorchStudio is now being restructured and re-architectured for remote training, and it will work exactly the way I've shown for this demo.
Nice. And kind of related, maybe start from the top down. Thanks for that question, Victor. I'm trying to find the question. I think it was from not yet. Where is it? Here is it. Is TorchStudio good with CPU, or do you need a good GPU for data processing? I think kind of related question.
Yeah, well, it's linked to PyTorch under the hood. So, well, it depends what your machine can do with PyTorch right now. CPU is fair enough if you have simple models. I think PyTorch is adding support for M1 CPUs in the future, and I think that it will be interesting to see what the Apple M1 CPU can do with that. But generally speaking, I would recommend a GPU for training, or if you don't have access to a GPU, since support for remote training is being added right now, you will either be able to use a server in the same building, or a cloud server which has tons of GPUs for you to be used.
Yeah, good question, not yet. So actually, before we dive into the other questions, maybe you could talk a bit about kind of what stage TorchStudio is at with release.
Yeah.
Helpful.
So right now, I mean, it's good enough for my own use, but I'm well aware that it won't fit every scenario for now. So I'm working on it, and I hope to have a private beta starting by the end of the summer or shortly after. There is a link, TorchStudio.ai. On this website, you will see a link apply to beta. And this is a list of contacts I'm collecting. So if you're interested, feel free to send me an email to this address. And I'll sure let you know when the first beta is available, but hopefully in the next 3 months, I think.
Nice. Yeah, related. It looks like there's a number of folks kind of sharing their interests in it and like what they would love to use it for. Let me just go through some of them. Naya, it says, I'd like to use TorchStudio for random data generation, maybe for his own NS data set, and potentially a lot more.
Yeah, well, it's funny that you mentioned the random data generator. All of those questions are scrolling very fast. Yeah, random data generator, because actually when you launch TorchStudio, the very first thing that is offered to you is a random data generator, which allows you to generate any kind of size of tensors, any kind of dimensions, because sometimes you don't have the data set ready yet, but you still want to play with how you could architecture your model. And this random generator is already available for you to generate any number of tensors, input, output that you need. And this way you will be able to check if your models is able to run.
Nice. Let's see. So we have another question. We have a question from Mark on Facebook. It says, will you integrate vision transformers and object detection into TorchStudio?
In TorchStudio, what's available right now is a couple of features. I mean, a couple of dataset and models that I add in addition to what the PyTorch library is offering. The PyTorch library, the TorchVision library in particular, is offering a lot of models and transform function. So you can access it in TorchStudio. But going further, it could be a nice idea to have a library of even more models and transform function that could be added to TorchStudio. I mean, as long as it's code in Python, you should be able to run it in TorchStudio.
Mm-hmm. Thanks for the question, Mark. So Matoki has a good question. I'm actually also very curious about how did you set up the UI? Like, do you use a library to create the editor? Yeah, what is the front end? How's it designed?
Yeah, 12 years ago, I fell in love with the Qt framework, and that's what I've been using for the past 10 years on spectral layers. And over the time, I've learned how to tweak the style of the UI. They have a very good still sheet system that you can use in Qt to make it look the way you want. So again, I've used the Qt framework for TorchStudio, which also allowed me to have this kind of result in very few times. I mean, I've only started TorchStudio 8 months ago, and it's a real time saver to work with this Qt framework.
Yes. Sorry, how did you spell that? Is it Qt?
Qt, but they pronounce it cute, like cute.
Okay, clever. All right, so let's see. Latong on YouTube has a question about, can I visualize the transformer architecture with TorchStudio?
Yeah, that's a good question, because indeed I made some initial tests. I wouldn't say that right now this is the best kind of visualization that I have for the transformer architecture, but as it's getting more and more popular, I'm definitely working on improving the graph visualization. That's something that I forgot to show in the software, but you can actually choose the level of complexity that you want to display on screen. You can display every single node, or you can display abstract view of your model, which are maybe easier to read if you don't need to dig that far into the model. So yeah, I'm definitely working on something that would work nicely with the transformer architecture.
Nice, thanks for the question. I think, and then kind of related is, are we expecting editing, be able to edit the network graphs directly from the GUI? You mentioned various ways.
I would say not at this point, because the focus of TorchStudio was to give the most control on the code side, so that you will be able to import any kind of Python model that you will get on the internet and get it straight away into TorchStudio. But I see it as an evolution in the second step for TorchStudio to be able to skip that code part entirely for the model part and connect your own modules from a library of modules. That's definitely something that I think for the future, not right now, but yeah, it's being considered.
Okay. Cool. Thanks for that question. So kind of looking forward, we have a user Pratik Korat from YouTube asking, is there any way that the audience could contribute? I know you mentioned you're doing a beta now and are looking for folks to beta test other ways to contribute.
Yeah, well, I think right now I'm finishing the first stage on my side, and starting late summer, beginning of autumn, when the beta will actually start. And feel free to send me any comment, questions regarding the questions of open sourcing or not TorchStudio. I'm still not fully decided about it because even though TorchStudio right now, the first beta won't be open source, you already have so much control over the feature themselves, because everything, it's a conductor for Python scripts. So basically you're already able to tweak most of the things in the software that you need. So yeah, I'm not still fully decided about the open source aspect of it, but right now I welcome any kind of comment, contribution, feedback. Yeah.
Nice. Yeah, definitely deciding whether or not to open source is a big thought. So yeah, definitely.
You can hardly go back after.
Exactly. So. Exactly. All right. So I know we're kind of running towards the end of time, but I think that was a very well spent time with us today. Okay. If anyone has additional questions, yeah, make sure to ask those kind of in the last couple of minutes. But how about, as we're waiting for last questions, I'll ask my last two questions to you. So any plans for TorchStudio to be able to handle, say, model interpretability in the future? Is that something like perhaps integrating with Captain Insights?
Oh, yeah. So I'm not sure if this will answer your question, but maybe it will. I've indeed, I'm planning to add additional analysis module in TorchStudio, maybe by gathering some very nice library that are already out there for PyTorch, like for one, debugging library, which gives you more insight of what went wrong when we try to build your model, or visualization library, for instance, to spot in a classification model, be able to see on the actual picture what contributed to the classification. For instance, showing it a picture of the dog. This kind of visualization would show you what pixel the model used to detect that it was a dog. So this is the kind of additional debugging features and interpretability features that will make it to TorchStudio.
Nice. Looking forward to that. And then last question. Oh, so we're getting some nice comments from Mark. So good feedback, good session.
Thank you.
Thank you. Thanks, Mark. And then Irfandi says, yeah, wow, just great tool. So highly second that. So maybe a general question that we like to ask on the show is, yeah, what are you most excited about in machine learning in general?
Oh, yeah. Well, I see that machine learning. I mean, it took me some time to figure out what it was and what it could be used for. And now I see it at this point as a way to interpret the world around us. That's a task that classic algorithm had a lot of troubles with, and machine learning is suddenly changing everything in that area. And for me, so machine learning is a way to convert the natural world and all its complexity into vectors that we can understand and play with. And then we can output results that are plausible in the real world as well. So yeah, yes, I see it as a way to interpret data, and I'm really excited about the potential of it. And I don't think people needs to I don't think we need right now AGI or super advanced artificial intelligence, because what we have right now with artificial intelligence and the state of the art is already mind blowing in terms of possibilities, and we're far from exploring everything that we can do with it.
Yeah, I like that thought on it. Like the first part of one, it helps us just understand this very complex world that we're living in. And I think with TorchStudio, that's like another, essentially creating the tools to help people be able to see these complexities in a way that is distilled and simplified that we can act on them. And like you're saying, like there's so much already. Like how do we kind of build from the most foundational, and like yeah, there's already so much that we can be building on. So I guess with that, we will wrap it up for today. But do you have any parting words for the audience before we wrap up?
Well, if you like the demo, or if you're interested or curious about TorchStudio, again, feel free to apply for the beta. You won't get an answer right away, but I will sure notice that you've contacted me, and we'll add you to the list of potential beta testers. So again, visit torchstudio.ai, which on screen right now, and click on the link apply for beta, and you will be contacted at some point.
All right, perfect. And let me get that off. And then yes, also his Twitter handle, Robin's Twitter handle at Divide Concept is on the screen.
Yeah.
So make sure to follow him. I'm sure he'll keep folks posted.
Absolutely, and feel free to send me a message via Twitter. I'd be happy to reply as well.
All right. Sounds good. And so with that, we will wrap it up for today. Thanks again, everyone, for participating, for watching, and contributing questions and comments to this session. Make sure to hit the like and subscribe button so you'll stay posted for our weekly sessions. And we'd love to have Robin back when potentially when you release or when new things come up with TorchStudio. Okay. Yeah, we'd love to share that. All right. With that, we'll wrap it up. Thanks.
Thank you.
Bye.